It's like
like some
no,
of
no,
our
no. That's right.
instructors
That's
actually.
right. It's actually we say like, but majorly we major questions are from 5 to 8, but of course you have to go through the entire weeks, like
Oh,
one
okay,
to
okay,
eight.
okay, okay, got it, sir, got it.
Sir, I think I need much means 3 times more practice than uh watching just a lecture. Means watching a lecture it's not sufficient for me as far as I came to know.
Mm. Mm-hmm. That's right. So that means you really
So
have to
like
work hard.
the
Yes,
week
sir.
6
Actually,
Okay. So this difficulty you're facing from week 5 or like all the
sir, I
weeks?
was like
kind of
practice I
Yeah,
didn't
week
practice
6
a
is
lot
beginner's,
in
yes.
qualifier one. So
Mm-hmm.
it was like very minimal practice for qualifier one. But when I
Mm-hmm.
went there and while giving the exam, I was able to solve 60 questions from
60
means
questions.
60%
Okay.
questions uh, and the questions which were having higher marks, like in the end, questions which were having 4 marks, I was
Mm-hmm.
facing lot of problems in that.
I see. I see.
Sir,
Okay.
and like for example, week 6 for the people who are from non-science background or
Yeah. Yeah.
non-maths, yeah, it will be really hard for them.
Yeah.
Like
Mm.
logarithms, functions, all that they might not know.
Mm-hmm. Agree. Agree. Correct. So, so week 6 is difficult. I understand in terms, even the activity questions are not that easy, right? It's not very straightforward. You
Kind of
need to have
twisted,
very,
sir. More like
yeah,
if you're being clear, so it's more of twisted things. So, yeah.
yeah. Okay. So at every, but this week is more about, you really have to respect the domains of certain functions, right? Whenever you solve, because you see more or less the questions are like, what is the domain of this and what is the range for this, right? And
Yes, sir.
where this function is defined and not defined and one-to-one function, right? And things like this, strictly increasing, decreasing, right? And you see log comes with composition of functions, right? It's like log of some functions, composite functions, right? So it's like it's not a single log, right? So first of all, log itself is scary, and then it is log of something, right? So I get it, but don't worry. Uh, Again, it's doable. I have one way which you can think of, but definitely it requires practice. This is something you should know. Okay. हाईएस्ट मार्क्स किसका आया है मैथ्स क्वालिफायर में देर आर सो मेनी so there are so many all over. Okay, what is that? Does it really matter? Did anyone get 100? Yeah, it does not matter. See, what I believe is if your concepts are clear and if you're just doing silly mistakes in your exam, that's allowed. But again, that is where you're not tested. That is something I know, that whether you know the concepts or not. Well, this is, but we look for perfection in terms of, concept knowing as well as your problem solving skills. So it's a combination of both. Well, keeping that side apart, so I think we can start our session now, right? So I think 20 to 20 of us are here. We can just simply start our session because it might prolong if we wait for others. They can see from the videos, right? What we have. Okay, one more thing. So how well are you with the week 6? You're finding it difficult, right? That is what I can see from you guys, right? Right? And what are you guys expecting from today's session? Could you tell me, like, is there anything that you want me to teach in specific, or like, should I give you my own way, like how I should approach this week 6? Like, what should be if the questions are like, okay, one to one, or like finding domain
Yes,
range
sir.
and
Yes, sir. Please.
So
okay,
that would be very, very good if you just,
okay,
like show your way of approach or something like that. That
okay,
would be very useful.
fine.
Also
So
some
we can
practice, some
also some
questions.
practice.
Yeah.
Okay, so let me think of, because I didn't come up with practice questions as such, but let me think of like what else I can give you. But yeah, certainly we can do something. Well, fine. So I don't know if my screen is visible. It's not visible, right? So I'll just share my screen. You can see my screen, right? All of you?
Not yet, sir.
Uh,
Yeah.
yeah,
Should be
it's
visible.
it's visible now.
All right, so we can just start with the thing. Okay, fine. So what all things we'll do is, I hope now all of you know what is this log functions. So let me just, bring you back. Why are we discussing this log at first place? Okay, so this black color, it's fine. So it's like week 6, and it is not going to be, it is actually going to be solved with us type only, because I'll be throwing you questions and I'll be creating my own questions. So on the spot, based on how you are and at what state of learning you are at, right? So that, like that, I'll be giving you questions. So you should actually solve those questions, right? And I myself will be solving those questions, so that even you get to know, okay, what is the approach for solving these questions, okay? So now see this, what all we studied in from week 1. It's just a quick recap. Just, I'll just get it done in 5 minutes. Say in week 1, what did we studied? We started with, okay, some very basic thing. Okay, what are like numbers and all that things, right? Then we started with something called the relation and functions, right? So then we started with what is functions, and thereafter we jumped into an function parts. For an example, straight line, it represents a function, right? A quadratic function, it represents a function again. Then we went with the polynomial, right? It is again a function. Then we went with next function called exponential, and then this is next function, which is logarithmic, right? So this is how the flow is going on, right? And if you have attended any of my live sessions, I have always told you, whenever we discuss a new function, you should exploit that function. First of all, what is the particular definition of that? What is the definition of that particular function? Then what else you should know about this? How does that graphically look like? Okay. Then what is, like, on general, what is the domain and range for that particular functions, right? Then these are the things, right? And then what are some other exceptional thing that you should know, right? These are the only things, right? This is all we do with the functions, right? So let's quickly think of it. uh, I assume all of you know this, what are the things. So I want all of you to participate here, okay? So it will not be like me just always telling it. I want you guys to interact with me, okay? So now we studied this, f of x is equals to, we know that, how do we write? F of x is equals to log x to the base a, right? And what are the condition? Now this is I'm something telling you what is the definition. So maybe just I'll just tell you on general what are we actually going to do today, okay? So first I'll discuss what is this logarithmic function, okay? What is this function itself? Then secondly, properties, which I will not be discussing because I think other instructors have covered this, like what are the properties. Properties means formulae, okay? So what are different formulas that you have, right? So this is something I'll not discuss here. I assume all of you know this, right? So I'll not discuss here. But what I'll discuss more is like problem solving, like uh, what, like, so more emphasis to how do we approach a problem, right? So that should be our strategy here, because even if you know all these things, you might struggle in, answering certain questions, right? Okay, so now what after this properties, what else? Our favorite, graphings. Okay, so we'll do with the graphing. So like what all things we can do the graphing. I think this will majorly solve all your problems. Trust me. Then what more do we have? Let's discuss certain concepts like what is this, like this thing, like what is a domain, then what is a range, right? Then what is this one function? So I'm not going to take you in depth, but when I'm doing this graphing, I'll be discussing all this, right? So these are the major things that we are doing here, right? So first, let's start with this thing. What are the properties? And at each stage, you have a question, okay? So it's not just going to be like this. I'm teaching you, a crude maths without any question. So that's never, it's not going to happen here. So keep that in mind. So first, let's start with this. So definition of the logarithmic function. So this is like, I know all of you because you're already come to, it's like solve with us session. It's like a third session and tomorrow you have submission date. So I assume all of you know what is this function. So f of x is equals to log x to the base a, right? And what are the conditions over here? What can you talk about a?
X should be A should be greater
positive.
than 1 and not equal to 1,
Okay, so A should be
Greater than
greater
0.
than 0 and
and
A
not
should
equal to 1.
Or
A is
not
not
equal
equal
to 1.
So if I have to represent this A in the number line, considering this is my number line which A
Start
represents,
with 0 and make
right?
open it.
Correct. So how does this appears? Let's say if this is 0 and let's say this is 1. So which all region does it cover? It covers this region, right? So it covers this region, right? And this
Yes, sir.
region,
Till
right?
infinity.
Right? So this is where it covers this A, right? And what about X? X, you have this freedom. So whenever you
X
say,
will be greater than 0.
It has to be greater than 0.
so whenever you say, okay, this function is defined something like this, so we have to make sure that X is greater than 0, because when you give, what happens when X is 0?
So it's undefined, sir.
Undefined. So undefined means it's something going towards infinity, right? So which side of infinity, positive or negative?
Negative.
Negative side. Okay, so like this is the normal definition. Okay, so now you understood what is about this A and what is about this X, right? So now this is all clear as if now, and all of you
Yes, sir.
studied this exponential function. Okay, fine, I'll not get into that exponential function here. When I'm discussing questions, I'll be doing this. So this is what the definition of log function is, and what all you have to pay attention to, this thing. Just by heart this, okay? Because a function, whoever has defined, let's say, because we have to follow certain rules, right? Like when you're dealing with something, right? So let's say let's say some of you at some point of time, let's say you do some kind of research and you come up with your own function. You know, you're saying that, okay, this is how my function is defined, right? So you should actually tell, okay, what is the definition of that particular function, right? What are certain conditions of that particular functions? Likewise, this is a log function. Let's say some scientist has given it, okay, and he has given set of rules saying that, okay, when X is greater than 0, X has to be greater than 0 and A has to be greater than 0 and A should
And
not
not
be
equal to
equals to
1.
1. So this is what that particular person has told, right? So this is all about this log functions, right? So this is something I have to respect at every point, right? So now let's jump more into this. So you know that properties, so I'll not discuss what are the properties here. I think you already know some of the properties of this log functions, right? So I'll just leave this as it is. I'll quickly get into the graphings, and I'll not exactly graphings, but I'll be discussing this graphings. Then maybe I can do this problem solving, I can say this, okay, which will go along with the graphings, okay? So problem solving approach. Okay, so this is what we are going to do now. So what do we really mean by this? So before coming here, I wanted to give you a hint about some graphics that we should know before going any further, right? So pay attention to this part. Okay. Now look at this. Now you yourself will be able to understand what I'm trying to do. Okay. So we have studied this, you know, like how do we really find the domain and range of this composition of functions, right? It's like composition of function. It's a very big thing, right? You have to follow some step-by-step procedure to get that, you know, the domain and range for that particular things. What I say is, okay, fine, that is one approach. I'll give you a graphical approach how to solve that kind of questions. Okay. So that will be much more easier. Apart from very theoretical mathematics, okay? So to a question, I mean a question to all of you before going to the graphing, I just want to ask a question to all of you. Okay, so now look at this. Now I have log to the power of 2x plus 5. Okay, so now this is one question, right? And I have, may say, okay, let it be question 1, and let's say another question where you have 10 log to the power of 10, and you have another same 2x plus 5, right? Okay, so now I have the graph. Now could you quickly tell me what will be the solution for this? What you will get when you
X
solve
plus
this?
5.
X plus 5, sir.
Okay, what about this?
2x plus 5.
2x plus 5.
All of you, with the properties, you can say it is 2x plus 5. Okay, if I have to draw the straight line, if I have to draw this line, okay, now understand this, there is slightly difference between these two functions, and what is that slight difference we always tends to miss out is something I want to highlight here. Okay, so now I think we all of us are expert to draw the graph here. This is y-intercept and this is 2, so I can just simply draw like this, right? Where this is my 5, right? So this is the graph for this, right? So 2x plus 5. So now question 1, now you have to tell me whether question 1 or question 2, or maybe like question 1 or represents this graph. Okay, so this is in a crude sense I'm writing it, so consider like that. So, okay, question 1 and question 2 both represents the graph. Neither. So can you tell me any specific?
That should be answered.
Sir, question one only.
The question one
Only
represents graph.
represents that. Okay. What about other?
Neither.
For other,
Neither?
x should be greater than minus 5 by 2 for question number 2.
Okay. We'll see
Neither.
that. Okay. Neither. Okay. What about nobody with the question 2?
No, sir.
Okay. So
No, sir.
what about others who are just thinking still? Okay. So these
Only
are the
A, only A.
only A you are telling.
Question 1 represent.
Question 1 represents. Okay. So let's see this. Okay. So fine. Look at this. Now, how do you solve these kind of thing? Okay. And how I was able to draw the graph. Okay. Fine. I got the end at the end that this is what it represents. Okay. So now let's quickly look at this. 10 to the power of 2x plus 5. Now look at this. This is an exponential function, right?
Yes, sir.
So it can take all. Now, what will be the output from this? No matter what x value you give, the output is always positive,
Yes, sir.
right? No matter what x value you give to this, the output is always positive, isn't it? Or let me say in other ways, I'm just trying to solve this here. Okay, so I'll just take it down here and then try to solve it. So let me say I'm taking question here. So all I have to make sure this, because you see this log 10 and whatever is there inside, I have to make sure it is greater than 0, right?
According to
Whatever is
definition.
given here, yeah, according to the definition, it has to be greater than 0.
Yes,
Let's
sir.
say whatever, let's say that if this is some variable, that has to be greater than 0 according to the definition, right? So what is that? It has to be greater than 0. 10 to the power of 2x plus 5 has to be greater than 0, right?
And
Now note
it is
this.
exponential.
Right,
So
yeah.
it is.
So now note this. This is an exponential function. So this is always greater than 0, right? All of you agree?
Yes, sir.
If I have to draw
Yes,
the
sir.
graph, it is always going to be some like this, right? It is always greater than 0. So this is
Yes, sir.
definitely right for all values of x, right? Right? For all
Yes,
values
sir.
of x, this is greater than 0. Therefore, this log function is basically defined for all the values of that thing, right? So when I'm taking log of this, so basically when I simplify this, I get this graph. Sorry, not the graph, but I get this, right? On simplifying. And over here, I can say that the domain for this, the domain of, let's say if this was the domain of this function is, what is the domain then?
Real, without any restrictions.
Without any restrictions.
All real values.
All real, right? So that is why you can see that, okay, if this is the output I get, and if I have to draw the graph for this, I notice this since this is defined for all r. So basically here x belongs to r. That is why this is been represented here, right? Because I'm free to take all the values of x, right? And that is why my straight line is defined like this, right? I mean, or it is graphed like this. Now let's go to the other part. Now this is 2x plus 1 and this is something we are getting it. So now I'll just take that part and see how does that thing happen. Okay, so now I'll just take this and see this. This is 10 to the power of log 10, log 2x plus 5 to the base 10, right? So 2x plus 5. So now again, this is log of something, then I have to make sure that this is greater than 0. 2x plus 5
Yes,
has
sir.
to be greater than 0, right? So
Yes.
for what value
Yes, sir.
it will be greater than 0,
Minus 5 by 2.
right?
Minus 5
So
by 2.
x has to be greater than equals to minus 5 by 2, which is nothing but minus 2.5. So x has to be greater than what? Minus 2.5, right? That means now if I simplify this, now this will be positive only when this is greater than minus 2.5. Okay. So now after that, whatever I get, this is an exponential function. So I really don't have to check anything for this. So this was only the constraint there, right? So I have to make sure that whatever I get here, now this is defined only when my domain is from where to where? Minus 2.5.
Minus 2.5
Minus
to
2.5 to
infinity.
infinity.
Yes, and minus 2.5 is not included. So let's say this minus 2.5 is somewhere, right? So where do you think that minus 2.5 is? Could you tell me what is happening over here? So this is what minus 2.5 is, I guess, right? Because
Yes,
at this value, the y is
Yes,
0,
sir.
right? So basically, and this is actually not included in my graph. So if I have to draw the graph for this particular thing, this part will not be there. And the graph will be only from here to here. So if I have to redraw this straight line, it has to go something like this. This is not included and it has to go like this, right? Therefore, Q2 cannot represent the initial graph which was shown like this here, right? Understood now? So I think
Logarithmic function
Yes, sir.
0, it tends to 0 but does not reach 0, no, sir.
yeah, okay, yeah, that's right. I'll come to that part in a minute. Okay, so yeah, I missed one more thing when I was explaining you the definition of a logarithmic function. I'll come back to this in a while. Okay, so now we are clear with this, like how these two are distinct, even though this is 2x plus 5 and even this is 2x plus 5, but what is the difference between them? There is a domain restriction. Over here the domain was R and over here the domain is minus 2.5 to infinity, right? So are you clear with this part? Right?
Yes, sir.
This,
Yes, sir.
so one thing
Sir,
that
could
we
you
have,
please explain
Yes, sir.
the first part again, how the domain is all the real functions?
how it is all real function. So you notice this, first of all, what we have to make sure is this is one function, log function is given to me, right? So in order to find out the domain for this particular thing, I have to obey the definitions of those functions, right? All of you clear with that? So now you notice this, when will that be greater than 0? I mean, when will that be restricting its domain? When this part is greater than 0, right? 10 to the power of 2x plus 5 is greater than 0, right? Then itself my log function will be defined, right?
Yes, sir.
Right? Okay. Can you tell me at what value this will be lesser than 0? Is there any value at which 10 to the power of 2x plus 5 is lesser than 0? Can you think of any values?
No.
Okay.
Sir, 10 to
Forget about the thinking
2x.
part. Now this is an
10 to the power of
exponential
minus
function.
2. No, 10 to the power of if the exponential is minus, like for example, if x is 10, minus 10 rather, 2 into minus 10 will be minus 20, minus 20
Okay,
plus
10 to the power of
5.
minus 100, for
But
example.
still, it would be 1 by something, right? So
Yeah,
it
that's
is
what.
still like on the positive.
0 point
Correct, correct.
something.
Yeah.
So let's say if you get something like this, this means what? It's 1 by 10 to the power of 100, right? Which is again greater than 0, right?
Okay.
It
Yes,
is
sir.
very near to 0, but it is greater than 0. So for all values, essentially this is an exponential function, isn't it? So exponential function is always greater than 0 if you have to look, right? So this is always greater than 0 for all values of x, right?
The
Therefore,
negative
the
values
domain
are
Yes.
not in range.
Hmm?
Negative values are not in range of exponential.
Yes, sir.
Why?
What, sir?
Okay, you mean to say
Sir,
range? Okay, yes,
sir,
yes, you are right.
range, sir, range.
Yes, yes.
Not domain.
Sir, I
Range.
got it. I got
Got
the
it now?
point.
Okay,
Yes, sir.
fine. Okay. So now I just missed one thing when I was explaining you that function. So I'll just quickly go to that part and discuss more with you bit graphings here. Okay. Then I'll take you to the other. So those questions were just to motivate you. Okay, fine. What all? So that was one approach by which we could actually, that was composition of function, right? And with some intuition and, restricting I mean, obeying the definition of a function, we were able to find out, okay, what is the domain for that thing, right? So now let's go deeper into these concepts. So how do we do this? Now look at this. Now this is my log function, and how does this graph look like? That is, let us understand this. Then I'll be building more on graphing part. Okay. So now if a is greater than, so if a is greater than 1, okay, so graph looks like this.
Increasing.
Yeah, it goes like this. If a is greater than 1, so this is my log x to the base a. So a is greater than 1, it can be anything. Okay. And what happens when graph is lesser than, when a is between this value, when a is in this interval, for an example, a is between 0 to 1, then what happens to the graph? Okay. And note this is actually what, when you give, this is 1. Okay. So because log 1 is what? 0, right? So this is always 1. So this is like 1 comma 0. Now over here also, notice this is going to be 1 comma 0. And now what is happening over here? The graph for this particular thing is going to go something like this.
Yes, sir.
Okay. So for all of you, this is actually going to infinity. So which side it is going? Positive side or negative side?
Positive side.
So
Positive side,
whenever
sir.
we say positive side and negative side, pay attention to this. Ask the teacher, okay, what is the value of A? Right? That determines it. So you're clear with this?
Yeah,
If
yes,
you're
sir.
noting, yeah.
If,
So now
if it is between
Sir,
0 and
Yes.
1, then it
the
will
graph
be
is something like
it-
this, right?
Yes.
Okay. Yeah. So now this is about this part. Okay. So now this is the graph now which we should know. Okay. And then we can build on more this or we can build more on this. Fine. So this much is clear. So whenever we talk about a function, we should first talk about what are the conditions. And the next thing is how does it graphically look like? Okay. Yes, Mayank, tell me.
sir, in first graph where A is greater than 1, so it's going downward side.
This one?
Yeah.
Yeah, it's going downward. Yeah. But you see what is
Downward
happening
and
here?
upward, sir. It is going upward now, sir.
No, basically
It
what
is
you
going
mean is like
upward.
in this interval, right? So this is something increasing, if you can see. Overall, this function is increasing itself. And what about this function overall? It is decreasing,
Increasing.
right?
Yes, sir.
Right? So clear?
Means it's means it's the perspective of view, right?
As x increases, y also increases. That means increasing function.
Yes.
Okay.
So that's why we are calling it as upward. It is not downward.
Okay, so okay, do not go with that thing. You whenever you want to look into a function, whether it is increasing or not, you should always think that what happens when x is going to infinity.
Going to infinity.
Right? You should not see like, okay, what happens when x is going to minus infinity. That is not the right way to see. Okay? Because
if
you might think like this, right? Don't think that way. You should always go like this, the opposite way. What happens when x is going towards the positive side? That's it. Okay, and then
in
you see
second
what is
graph,
the
I
behavior
can
of the function.
apply this that x is going to infinity, then y is also going to infinity.
When x is going to infinity,
And
then
y
y
is
is
also
going to
going infinity in second graph. If I
minus
consider
infinity.
minus infinity, okay. Oh,
Right?
okay.
Why?
I
Because
thought
this value
it's
will
going
be
to
decreasing.
positive infinity.
Okay.
Yeah.
Okay.
Can you quickly repeat why negative base is not considered?
Because this is the definition of a function.
Hello. Your voice broke, sir.
It's a definition of a function, of this particular function.
Okay, my question is, suppose -1 we have and we square it, we will get 1, right?
Minus 1 you have.
If we square it, we will get 1, right?
Yes. Okay.
So if we can define as, okay, log 1 to the base -1, it will be 2.
You want to say like this?
Yeah.
Okay. Tell me.
No, log 1 to the base -1.
Okay. First of all, it log 1 to the base.
-1.
But how can you
It's
say that?
not,
Because
no, a is not equal to 1, sir.
No, here I am considering x as 1, right? Log 1 to the base -1.
log 1 to the base minus 1.
Okay.
-1, it will be equal to 2, right? Because -1 square is 1.
How are you saying it's going to be -1 square? And where is that square coming from?
No, if I write it as an equation and if I take an exponential on both sides.
You
Log
mean to
1
say-
to base, like log 8 to the base 2, we have 3, right?
Okay. So let me give it this way.
Like
So
by how
she-
much?
Let
So
me give it
she's
this
trying.
way. Okay.
So she is trying to say log base -1 and 1
Yeah.
equals to 2. She's trying to say that, I guess. So in that case, if you take the exponent,
Base is
that
-1.
means- yeah, base is
On
-1
top,
and
we have 1.
1.
The value
that
would
is
be
equals
by
to
how
2.
much? Yeah, the value would be by how much power we should increase the base so that we will get the top answer. That is the back end of logarithm, right? Like log 8 to the base 2, we cube the base and we will get the answer. So that will be the case.
Okay.
This is just
Okay.
equal to 3, right?
Yeah.
But if
Yeah.
if we
in the same
include the -1, then we'll not get the 1. I mean, then it will be -1. So it will not be consistent. That's why we don't use minus in the base.
Okay.
A is greater than 0.
Is it okay?
It will only work for even powers, right? Like on the right hand side, if
Okay, he means to say that -1 need not be squared. It can be power 4 also. Then it will be 4. Then it will be 1 and so on. So answer can be 2, 4, 6, anything. Is that what he's saying?
Yes,
It's
exactly.
inconsistent actually. That's the
Inconsistent.
thing.
Okay, if we change the numbers like log 8 to the base -2. Okay, but again log -8 in anyway it's not defined. Okay, there is something that I'm missing.
Is log defined for values of a less than 0?
No.
You should pay
No.
attention to definition of log.
Okay, so let's
Yeah.
go to the next topic of ours. Is it okay to all of you?
Yes, sir. Yes,
Yes,
sir.
sir.
Okay.
Yes, sir.
Okay, fine. So now, okay, fine. So let's look into some graphing aspects. Okay. Now look at this particular thing. Now, if I have a straight line, okay. Now let me say my straight line is something like this. Okay. So let's say this is y is equals to 2x plus, let's say 5. Okay. Now, if I have to take, now this is what my log is now. I mean, the function y is equals to 2x. Now, if I have to take log of 2x plus 5, suppose, then what will be the graph? What will be the graph?
Graph will be similar to that log
It has-
when a is
Understand
more
this?
than 1.
Understand
It
this?
will
Now
be
look at this.
same, but
2x plus 5 is something this y
it
value,
will-
right? Now just pay attention to whatever I say. 2 of a,
Sir,
2,
asymptote is changed.
okay, I'll come to this part. Just understand something. You are right.
Okay.
Log of 2x plus 5. Okay, so now I have to find out the graph for this particular thing. Okay, so now 2x plus 5 is what? Basically the y value of this on this line, right? Y value on this line, isn't it? All of you know
Yes,
this,
sir.
right?
Yes,
2x
sir.
plus 5
Yes,
is the
sir.
y value, y coordinates on this line, right?
Yes, sir.
Right? Okay, so now I have to make sure at what value this 2x plus 5 is 0. I mean, at which place the 2x plus 5 is 0? Can you tell me? This is that place?
So -5 by 2.
5 by 2.
So this is that place.
Minus 2.
Look at the graph. Forget about the value. Look at the graph. At where it is being 0. Can you tell me? At this
That
place?
green dot.
Yes, sir.
Right?
That's green dot.
Okay.
Yeah.
Green dot.
What about these values? These are some negative values.
Yes.
These are
Log of
basic
this
structures.
negative value is not defined,
Yes.
right?
Yes.
yes,
And log of at this point will become infinity. So it is going to
Yes,
form
sir.
an asymptote. Now this is increasing part. So how will the graph go? Like this. So is this the graph for this?
Yes, sir.
Yes, sir.
Yeah.
Okay.
It
Now you understood this
would-
part?
So, sir,
Now-
so sir, the asymptote would be that exact point, right, where the y value is getting 0. I
Huh.
mean, at
So
-5 by 2.
asymptote is x is equals to -2 by, sorry, 5 by 2.
-5 by 2, right?
Yes, you're right.
Perfect.
Sir,
Perfect. Got it, sir.
what will be the x intercept?
X intercept for this. So how do you get
Yeah.
that? So basically you have to equate this to 0 and find out. Okay. So this is eventually, if this is to the base 10, so for what value 2x plus 5 is equals to 10 to the power of 0, right? So this is going to be 1, right? So this is going to be 2x plus 5 is equals to 1, or I can say that this is going to be x equals to -2, right? So at
-2.
what? Okay, so x equals to -2, you get what? You see
X
this is being
intercept.
0, right? So this is being 0 is something here. So this is -2 basically. This is your x intercept, right? You got it?
Yes, sir.
So now you understood, right, what I'm trying to do here. Now just focus on the graph, okay? Do not go with the math part, and then we'll come to the math part, okay? And then we'll do some analysis. What did we do here is, because if you don't understand this, I cannot build on more here, okay? So this is some foundation where I'm trying to take you like log of anything. How do you actually find out the graph for this, and how do you actually find out the dominant range, okay? So now I had simply drawn the line for y is equals to 2x, right? And I have just looking at the output values for all of this. Over here, y is positive. Well, my log will be well defined if I'm taking log of this, right? Over here also it is positive. This is the where it becomes 0. So wherever it becomes 0, I think that is where my log becomes infinity, right? It goes to -infinity if this is greater than 1, right? If my base is greater than 1, right? So now what is happening? What about this region? This is giving me negative output, right? 2x plus 5 is basically negative, right? So if this is negative, where my log function is not defined, right? Now, if I have to ask you, what is the domain of this particular function? So what you will say?
It will be
Greater than minus
greater
5 by
than
2.
minus 5 by 2.
Now look at this particular graph. Now what is this?
Minus 2 to positive infinity.
Minus 2 to infinity.
Minus 2
Minus
to
2.5 to
minus 2.5 to infinity.
right, and where minus 2.5 is not included.
Not included.
Right. So all of you clear? Looking at the graph, we can say, right? All of
Sir,
all these things.
Is it minus 2.5 or minus 2? Okay, minus 2.5.
Minus 2.5. And you just have to tell this is not included. Right?
Okay.
The exact value of this is not included. So now clear with this. Now should I build on more on this?
Yes, sir.
Let's get into the other part.
Sure, sure.
Yes, sir.
Sure.
Okay, so I'm not going to erase this, but I'm going to take out some other part on this. So, okay. Now look at some more things so that things become more interesting. Okay, so now I'll just change the pen color. Now this was first example. Let us take another example and try to understand this. Now all of you quickly look at this. All of us know what is this, right? What is this?
Parabola.
Quadratic.
Let me
Graph of
say-
a quadratic equation where a is equal to more than 0.
Yeah. Yes, right. And what about the discriminant?
Greater than 0.
Greater than 0, sir.
So all of us are like very well aware of this. Okay. So now look at this particular function. Now I'm not going to draw any equations or such, or let me just give it for this example, and thereafter I'm not going to do. Okay. So if I say the leading coefficient for this particular quadratic function is 1, and if I have to simply draw the graph, so I know that it is going to be x plus 3 and x minus 3, right?
Yes, sir.
Right? So this is what the quadratic function this look like, right? So now let's discuss. Okay, so I'll mute all and then I'll discuss. Okay, so now understand this. Now what I'm trying to do here is I'm basically trying to go one more step over here and trying to find out what is the log for this. Okay, so now I'll take log of my f of x, which is x plus 3 and x minus 3. Okay, so how will this graph look like? Let's understand this. Okay, so now I know this, whatever is the output that you get, like, of course, the y coordinates on this graphs are what? The output that I get from here, right? So it is the output of that only, na? So where it is becoming 0, at 3 it is becoming 0.
Yes.
Right? So I will say that yes, there is one asymptote, and in all the assumption that whenever I'm writing log, I'm writing basically a greater than 1. So assume this is 10 here. So how will the asymptote be here? It is going to be something here. What about at 3 also, no? At minus 3 also it is becoming infinity, it is becoming 0. Look at this
Yes,
graph,
sir.
this is where it is becoming 0. What about these values?
Yes, sir.
These are negative.
Yes,
Can
sir.
my log take this negative value? No.
No.
Not. It cannot. So now what will happen? This is increasing. So what will happen to my log function? Increase, go something like this. What about this? This is also, this was decreasing in terms when you're coming from this side. But as you go this side, what is happening? This is like increasing, right? In this
Yes.
aspects, in this side, in this direction. So now
Yes,
what
sir.
if I have to simply draw the graph? As this is increasing, I mean, this value is increasing. So even this will increase and it will go like this. So now look at this graph. Now this graph is basically log of this. Now whatever you see, this is in the green color. This is the graph for this log of x plus 3 times x minus 3. All of you clear?
Yes, sir.
Yes, sir. Yes, sir. Very clear.
Now you're able to draw the graph for quadratic also, like log of some quadratic thing. We shall be able to do.
Yes, sir.
Yes, sir.
Okay, now let's build on more on this. Okay, and then see how is it happening. Okay, now if you are to ask me, okay, what is x-intercept, what is y-intercept, how will you do that? Just equate to 0,
We will
because you have
equate
to
to
make
0.
sure that where it is being 0, right? Yes, Mayank, tell
Yes.
me.
Sir, for any graph, we can draw log graph.
Yes, exactly. That is what I'm coming there. So now I'll come to that part. Like slowly I'm trying to build this. So how is that happening? All I'm doing is I'm obeying the definition, right? I'm making sure that it's not being 0 at that point. I mean, for 0, it is being not defined. So, well, I'm something obeying that. Now let's get into
Yes,
the
sir.
third part. Okay, so maybe I'll just use some different page altogether. Okay, so now let me get into this. Are you getting some background noise?
No, sir.
No, sir, it's
sir, it's
clean, sir.
fine.
Okay, fine. Because
Temperature
I'm
is
totally disturbed here
okay.
because of this background noise. Okay, so this is not question 3, but it's like get into third aspect of it. Now, what is this third thing? Let's say I have an polynomial like x minus 1. Let me call this as function f of x is something like this. X minus 1, x minus 2, x minus 3, right? This is, or let me give it as x minus 4, just to, okay. So now, as if now I believe that you have come from your qualifier and all of you know how to do the graphing. So what is the degree of this? Degree of this
4.
polynomial?
4,
4.
sir.
4.
So if I have,
4.
and the leading coefficient is positive. So all of
Positive.
us know that. So now what? I simply have to draw the graph for this, right? So how do I do this? I know that this parabola is going to something look like this, right?
Yes,
Yes,
sir.
Yes,
correct.
sir.
Okay. Not parabola. Yeah, like this is how the
Like
endings
the
are.
end behavior.
End behavior.
Right,
End
right.
behavior.
So now what I'm trying to draw the graph for this, right? So this is going to be something like this, like this, like this, like this, right? This is what it is. Okay. So now what I'm trying to do here is, let me say my g of x is equals to, you know that what it is, right? Log of this, is
Of
it?
f(n).
So now let me take log of x
F
minus
of
1, x minus 2, x minus 3, and x minus 4, right? And let me try to draw the graph for this, okay? So now, of course, what is this you notice? Wherever the x, I mean, I have to make sure that this is greater than 0, right? Then only my function will be defined. Which all are the regions where it is greater than 0?
Minus infinity
This
to
region,
1.
this region,
1
Yes,
to,
sir.
and this
yeah.
region, right?
2
These
to
are the
3
only
and
region
4
where
to
it is
infinity.
being greater than 0, right?
Yes, sir.
Okay. So now let's understand more from here. Now again, what is the value of f of x here? 0. F of x. What is the value of f
4.
of x?
0.
Yeah, 0.
0, not 4. So what
No,
will
at
happen? What
4.
is f of 0? F of 0
4
is
will
what?
be x is equal to 4 asymptote.
Sorry, not f of 0, but what is log of 0? It is an not defined condition, and you know that how it goes, right? So now what? Now this is increasing, so I'll have to increase this, right? So it goes something like this, right? What about this region? Now this is the region where this is being negative, right?
Yes, sir.
Right?
Graph will not there.
So basically my log will not be defined there, so I cannot have a graph there. Now what is happening at 3? 3 is again it's being 0, so again I'll have an asymptote here, right? At 2 also it is becoming 0, again I'll have an asymptote here. At 1 also it is being 0, so again I'll have an asymptote here. Now I'll just try to reconnect all these. Now what is happening? This is increasing, right? So this will also increase, and this is decreasing, so decreasing. Okay, fine, it will decrease like this. Okay, clear all of you?
Yes,
Yes.
sir.
Okay, now what this is, again this is a positive value, and this is basically decreasing if you go in the positive x direction, but as you go in the negative x direction, this is again, it's like
Yes,
the
yes.
value is increasing, right? No,
Yes,
f
sir.
of f value is
Yes, sir.
increasing.
Yes,
So
sir.
what will happen to your
Yes,
log
sir.
function? So it will go like this, it will increase. Okay, so now whatever the graph you see here, this which is marked in red, this is the log graph of this particular thing. So clear?
Yes, sir.
Okay.
So, sir,
Now,
basically, we
Yes.
need to find the zeros of any polynomial to draw the
exactly,
log of that graph, right?
to draw the asymptote, and then see
Yeah,
what.
yeah, the asymptotes, yeah. So,
Yes.
and then we can just draw the basic graph without the log, and then we can just do this.
Mm-hmm.
Okay,
Right?
perfect.
All of you clear with this? Yes, Mayank?
Yes, sir.
Sir, the left-hand part after the one,
Voice is breaking.
Yes, sir.
the graph is saying that after
Yes, yes.
the left-hand part, the graph should decrease as x-axis is going towards negative infinity and y-axis is going to infinity. So I'm little confused
Yeah.
that graph will decrease or increase.
You understand
Means
this?
can you
On general, this is
explain
neither
it?
increasing nor decreasing, right? On general, if you are seeing.
Okay.
Now, what is happening over here? Just look at this part. What I'm trying to see here is, if this is more, then log of something more is more only, right? Right?
Yes, sir.
Right? If this is less,
Yes.
then log of something less value is also less. Right?
Yes.
Log of 1 is what? 0.
0.
Sorry, log of 0 is what?
Uh,
Log of 0
log
is
of
not
0
defined,
is
which is something shown here. So
not
if this
defined.
is, look at this.
Asymptote is on.
Now in this region, what is happening? This is decreasing. What is happening to your log value? Decreasing. If I
Yes,
come in
sir.
this direction.
Okay.
Clear?
Okay. Yeah.
So
Yes, sir.
right?
Yes, sir.
So you have to always look when x is increasing, what is happening to your function. So you will be looking this way.
In general, it's neither positive. It's neither increasing nor decreasing. But but when I look at the original graph, by looking at the original graph, I can say that it's decreasing.
By looking at the original graph, you can say
Yeah, green
this part.
line.
Yeah, you can see it is decreasing, and
Yeah.
even this log of decreasing function is again a decreasing, right?
Yeah, yeah.
Right?
Okay.
Okay. So now,
Okay.
now look at this.
So
All of you, just a minute.
Sir, one doubt, like when x is in between 2 and 3, so
Go ahead. You're on.
yeah, then the y, the red line, the red u, the red reverse u, which you drew between 2 and 3, it cannot have positive values, right?
It may or may not have, but the characteristics of curve will be like this. Okay. It can even happen that this is going like this, right?
Yeah,
It
that
can even happen
it
that.
should be like that, I'm saying. It
Need
cannot
not be, right? What if
like
this value is, let's say, what if this value is 10?
no, sir, in between 2 and 3, I'm saying.
Yeah, in between 2 and 3 only I'm saying. What if the value is, let's say, 2.5
So
comma 10?
log, red thing.
Yeah, I'm coming to that part. Let's say this point is 2.5 comma 10. Okay.
Yeah.
So this 10 will be the input for your log function. So what is log 10?
Why would 10 be? Yeah. Right.
You understood?
Right. Yes.
Log 10 is 1 then, right? But
if even if I put 2.5 in the green line, I cannot get 10 as the answer.
Okay, I understand in what aspect you are saying, but I'm talking in general.
In general,
Right?
okay.
Yeah, because of course you can substitute the value and see what is the thing, but it may or may not be crossing this line, right? It depends on this peak value.
So we cannot conclude number of zeros of f of x is equal to number of zeros of g of x.
Yeah, you can say
Right?
that. Yes. You're right.
G of x will have a zero only when f of x value increases 1. Log 1 is 0. Right?
Yeah, but you can at least say what will be the minimum number for sure. The minimum number for zeros are definitely 2 in this case. That is something we can say, right?
Minimum is 2, but we are not sure of this 2 and 3 part, right?
Yes. That you are right. Because we know to know what is this peak value. Definitely.
Between 2 and 3, what is the peak value? We should know. Only then we can
Because
tell g of x
exactly.
will cross 0 or not.
Yes, you are right. Okay. So now look at this. If there was no graphing knowledge for you for time being, how you would have found out the domain for this? Could you tell me what would have been your approach? You would have made sure that, okay, for what value this is greater than 0, right? And then eventually you would have drawn some kind of visual analysis only, right? Or you would have done some kind of mathematical work, right? It would have been difficult, right? Now it is very easy for us to tell, okay, what is the domain? Now look at just this red part, okay? Over here, what is the domain? Minus infinity to 1, right? So I'm just trying to do this minus infinity to 1.
Open bracket.
2 to 3.
Add open bracket, union.
Open interval, right?
2, 3. Open
2
bracket.
to 3.
Then
Union.
4 to infinity.
4 to infinity.
So now life is easy how to find this domain.
Yes, sir.
Right? So now we can actually find out, okay, what is the domain? Could you tell me what is the range for this? Range of g of x?
It will
What
be
is
Minus
the
infinity to infinity.
Exactly. What is the least value this function is taking? It's going to minus infinity. And what is this value? It is approaching to positive infinity. So minus infinity to positive infinity. This is my range. Okay. Now tell me, is this function log of something like this is 1-to-1 function?
No, sir.
No,
So
sir.
it's not one.
Just
Many
draw a
one.
horizontal line.
Our
See?
horizontal line test fails.
Yes, it fails, right? It fails, isn't it? So all of you clear?
Yes,
But
sir.
if I restrict the domain and if I say this g of x is defined from, let's say, 4 to infinity. So is this 1-to-1 function?
Yes, sir.
Yes.
Yes, sir.
Because I'm restricting the domain, then I'll be just left with this part. And this
Yes,
part
sir.
is definitely 1-to-1, right? Because it is strictly increasing. All of you clear till now? Let's move to
Yes,
the
sir.
next part.
But I
Yes, sir.
still didn't
Yes,
get
sir.
how can it cross the x-axis between 2 to 3.
You mean to say when you are doing horizontal line test?
No, sir. The previous question itself, when x is in between 2 and 3, how did it cross x-axis?
How did it cross the x-axis? Oh, that
Yeah, the red
something
line.
I
The red
explained.
line.
That's what I was trying to say. It may or may not cross the x-axis.
Now, how
Will
can it cross
only
that?
if g of x will be greater than 0.
How it can cross means?
No, if whatever value I take in between 2 and 3, f of x will be less than 0. F of x might or might not be.
Okay. Could you tell me what will be the value over here? It will be positive or negative?
f of x,
Yeah, f of x,
it will be positive, I guess.
positive. If it is a positive, that is the positive value will be the input for your log function, right?
Yeah.
Right? So
Yes.
that is the value you are taking. You're not taking the x, no? You're taking the value of this function f of x. You understand? So if it is now, go ahead.
So that means f of x, if it is greater than 1, then g of x is defined there, sir. Between 2 and 3.
Between 2 and 3, if f of x is greater than 1.
Than 1.
Yeah, exactly.
Okay.
If it is like 0.9 or let's say 0.5, then what? What will be the value you will get?
That will be negative. So
That will be negative, right? In that case, this will not cross the x-axis, right?
okay, yes.
All of it clear?
Yeah.
Okay. So now having known this, now for any graph, okay, now let's go and generalize this. Now if I have given any graph, let me not know any graph, okay, what is that? Okay, so if I have to tell you simply, okay, you know the sine curve, right? How is the sine curve? Like this, right? All of us know. This is, let's say this is sine x, right? Now if I say draw the graph of log of sine x, to all those who don't know what is the graph of sine x, assume this is some graph given to me like this. How will I draw the log graph? I mean log of this. Okay, so let's quickly draw this graph. Let's see what will I get. Now over
Wherever
here it
it
is becoming
crosses
zero.
x.
Wherever it is getting
Exactly,
zero, we will
exactly.
make asymptotes.
Correct. Now let's understand this. These are all the places where it will be zero, right? The sine x is becoming zero. So at this place I'll have my asymptotes, right?
Yes.
These are the places where I'll have my asymptotes.
Yes.
Right? Okay, over here, how many asymptotes did we get? How many asymptotes do we
Finite.
have? Not infinite. How many asymptotes we
6.
had for this?
4.
6,
Oh,
sir.
For
1,
this
2,
graph,
3,
6.
4.
4.
Over
Yes,
here, we
sir.
had
Oh,
just
in
4
that 4,
asymptotes.
yeah.
Yeah?
4
Right?
asymptotes.
Okay.
Yeah.
So now understand this. Now look at this. Now this is increasing, so this will increase. And let's say it is crossing somewhere, but actually it will not cross because this is sine x, right? And what is the maximum
Yeah.
value of sine?
1.
Yes, sir. It
1.
will
1.
cross.
So it will just
Yeah,
touch
so it
and
will
go.
simply go like this, right? Okay.
So it will
Yes,
touch,
sir.
right?
Sir, it
Log
will
1 is
touch.
0.
It
It
will
will
touch.
touch at 1
So
because
it will
log 1 is
touch at
1.
1.
Yes. All of you are right. What is sine 1 is what? Log 1 is what? 0, right? So it will just touch
0.
at
0.
1 place. Right. So
At
this
n5
goes like this. Again over here, what will happen? This will go touch
Then, sir, touch.
and come back. Again here, it will come and touch, right? And it will go like this, right? So all of you can see the graph. How does it look like for log sine x? This is how the graph look like.
Yes.
So now you
Yes,
can
sir.
do the graph of any function. If it is like log of anything, you can draw the graph, right? Can I assume that you can do that?
Yes, sir.
Oh,
Yes.
yes, sir.
Okay. So now you got some learning from here. Now again,
Sure.
now if I have to ask you what is the domain for this particular thing, right? So you can, okay, forget about the sign. We are not dealing much with this. So forget about this for time being. Okay. So now this is all about this. Now what if you have questions like this? Now let's get into some trickier thing. Okay. So now what if you have like log of
So
log
once
of
again, just for the log
log
of sine x.
Do you want me to give some more log or just stop here?
No. Yeah,
Or
stop.
just understand this? Okay. Yeah. You were asking something with sign. Yes, please.
Yes. The domain would be R and the range would be minus infinite to 0. Am I right?
For what? The domain for
Log
this?
of sine x.
How
Log
can
of
you
sine
say
x.
the domain is R?
Because it will be defined for all the
What about this
continuous
interval?
sine
What
x.
about this interval?
Okay.
Right?
Okay, fine. Yes.
Yeah. So it is discontinuous
And
graph, right?
okay.
Clear?
Yeah. Thank you.
Okay. So now let's get into this part. Now this is like log of log of log of log. Now what do I do for this? I think you have some questions in your activity thing, right? Let's say base is something, whatever, let's say 2 or like 10 or whatever. Let me give it some positive value only and let's do some concept building thing. Okay, so how will the graph look like for this? So what
Yeah,
I'll do?
it should be
First,
horizontal line for.
okay, so what I'll do is I'll simply blindly draw the graph for log x, first of all, okay? First, I'm trying to draw the graph for log x, okay? So now my log x graph is something like this. I'm done with this part because this is what we were doing, no? Log of
Yes,
some
sir.
polynomial it was given, then first we drew
Yes,
the
sir.
graph of polynomial, right?
Yes,
So
sir.
log of x I drew, okay? Now what I'll use a different color. maybe I'll use blue here. So now I have to make sure where all it is positive, right? So it is this value where it is becoming 0. So I know that when I'm talking about this log, so this log will be defined, this over here it will become what? It will have an asymptote, and this will slightly bend like this and it will go, right? So I'm done with these two things. Now I'm done the graph. Now I have drawn the graph for this, right? This blue color thing I have drawn the graph. Now it is log of that as well, right? Now log of this blue color thing, right? So now you know that log of this blue color thing will be what? Again, this is becoming 0 here. So this asymptote I'll have here, and this is increasing. So even this will increase. So I'm done with basically this part as well. This much graph is this black color thing, right? Now let me go with the last log and understand this. Okay. So now what, maybe I can choose some other color and
Green.
Green. Okay. Let's go with the green. Fine. So over here it is becoming what? 0. So I know that this is where my asymptote will be, and this is how the graph look like. Okay. This will increase like this. Now let's do some analysis. Okay. What is really happening here? Let's understand this. Okay. Let's go with the numerical value. Okay. So now at what value this is being 0?
So
Now
1,
let's
0.
let us find out what is the domain for this particular thing. Let me say this is my f of x. What is domain of f of x? Then everything will be clear. Okay. So over here at 1 it will become infinite. Sorry, at 1 it will be 0.
It will
Log
be
1
0.
is 0, right? So this is 1, right? All of you clear with this? This is 1.
Yes, sir.
So at 1 this is becoming infinite, right? Now I'm done with this part, right? Log 1 is, this is log 1. What about this? What is the value for this?
10.
10.
10. All of you clear?
Yes,
What will
sir.
happen is, what will happen here is, now this is log 1. Log 1 is
Sir, it will be
infinite.
10.
So this has to be 10 for it to be what?
1.
Right? So over here, this value is what? X value is 10. Now what about this? Essentially, I can write 10 to the power of 0, 10 to the power of 1. What about next?
10 to the power
100.
of
Yes, sir.
10 to the
What
power
about
of
this?
10.
10 to the power of 3.
Thank you.
Right? So
Yes,
now
sir.
you
Yes,
understood this? Okay. So now if I have to ask, okay, what is the domain for this particular thing? Then what is the domain for this f of x? 10 to the power of
10 to the power.
2 to the infinity.
2 to
Yes, sir.
infinite.
Yes, sir.
Clear? So it becomes easy, right? Now if I build on whatever, now you're able to find the things, right? Now if you try the activity equation, this will be easy, right? All I have to do is simply draw the graph. Yes, ma'am.
Sir, I have a question.
Yes,
So
yes.
for the, is it 10 to the power of 2 or 10 to the power of 10 there, sir? The third
Oh.
one.
Third one here.
Yes, sir.
Oh,
No,
what do you think?
first is 10 power 0. The second one was 10 power 1. The third one is it 10 power 10 or 10 power 2, sir?
Power 2, no?
So when we do the log.
Okay, wait. Yes, you
twice.
pointed it out. Wait. Let's go with, let's understand this. Okay. Yeah, I think I missed some point there, and I just went on with this. Okay, so now I have to make sure that this, for what value this is being 0. Now what are we doing here is log x, for what value it is being 0, right? So now we understood this. This is to the base 10. So what will happen? X is equals to 10 to the power of 0, which is making me 1, right? Which is this part. So essentially what am I doing is 10 to the power of 0 is something I have written here, right? Now I have to make sure that for what value, now I'm taking this part, right? For what value this is being 0, right? So I'm taking log of x, right? For what value this is being 0, right? And this is to the base 10. So what I'm going to do is I'll simply take this 10 to that side. So this will become 10 to the power of 0 and log x, and this is to the base 10. So this is 10 to the power of 0 is what? 1, right? So
Yes,
essentially
sir.
what am I doing here is x is equals to 10 to the power of 1, which is something we have written here. Well, that is fine. Now let's get into the other part. Now I'm taking all these three. Now what I'll do, I'll take the same thing, log of log x, right? I'm not writing that graph, I mean bracket thing. You can understand this. For what value this is being 0, that is something I have to find out. Okay, I'll go from this. This is to the base 10. So what will happen? I'll write log 10 to the base x is 10 to the power of 0. I've just taken this 10, right? I'm just writing in the standard way, the way we write. So this is 10 to the power of 0 is nothing but what? 1, right? Now what about this? This is going to be log 10 x 10 to the power of 1, which is 10 itself, right? So where this is fine. Now what about this? X is going to be 10 to the power of 10. Well, thanks, you pointed it this out. Now this is going to be what? 10 to the power of? So this part is going to be what? 10 to the power of 10, right? Eventually, the next thing will be what? 10 to the power of what? 10 to the power of 10 or 10, right? So this is going to be 10 to the power of 100, right? So this is going to be, this part is actually going to be 10 to the power of 100, right? So eventually the domain for this particular thing is 10 to the power of 10 to infinity.
10 to the power
Sir,
of 10
10
to the
power
power
10
of
power
10, right?
10.
Not 10 square, right? 10 power 10 power 10. 10 power 10 you wrote as 100, sir.
10 to the power of 10 I wrote, right?
10 to the power of 10.
No,
After that,
in on the x-axis, the
Okay,
fourth point,
Yeah, I got it. Which I have written it as 100, which is incorrect.
no, it's 10 power 10 again.
Yeah, it should be 10 to the power of 10 to the power
10 power 10.
of 10. So it is going to be something like this. 10 to the power of 10. So maybe I can use more brackets here just to distinguish this. Okay. So now what? This is what we get. 10 to the, okay, let's not give it this. This will, you will tend to multiply then. 10 to the power of 10 to the power of 10. Right? So this is what you get the domain for this.
Sir, domain will be 10 power 10 only, sir.
Domain
Yeah,
will be
that is
10
right.
power
Yes.
10 only.
Because this is something we are taking, right? So this is going to be 10 to the power of 10 to the
And the
power.
last
This is
0 will be 10 power 10.
10 power.
Which we are not interested in that.
Yeah.
Domain will be 10 to the power 10. And why not 10 to the power 10 to the power 10?
It's just because look at this. Now this is this green line, which is the my function f of x, right? So this green line is from where? From here, right?
Yes, sir.
So 10 to the power of 10, which is not included, to infinity.
Okay. Okay.
So now clear with this?
Yes, sir.
So now let's do some more problems, which is not very nicer like this. Okay. So let's take some more problems and try to do this, how it's going to happen. Okay. So now if I have to give you one more question, like, okay. So now all of us goes with an assumption that, you know, the range, the range for a log function is minus infinity to minus infinity, right? So there are some instances where it is not, right? Now all of us are convinced with that. Now say if I have a quadratic function, something like this. Now if I have to draw the log of this, how will the graph be? Log of some value over here, right, which is positive. Then log of some positive value will be something like this. Maybe it will be here. Okay. And then what is this happening this side? It is increasing. So this will also increase for sure, right? This will also increase for sure, but it will increase at a very less rate, right, compared to what this quadratic is. And what about this? This will go in this fashion. Okay, there is no bending here, but yeah, this is how it's going to go.
Sir, there would be slight bend, right? Not a huge, but slight, right?
Yeah, slight bend. So if I have to say this is x square plus, let's say, yeah, let's give it as 10. X square plus 10. If this is the graph for x square 10, then what is the graph for log of x square plus 10? If this is 0, 10, then what is this? 0, 1, this point. And this is how the graph look like. Okay. Now, if I have to ask you, okay, what is the domain for this? What is the domain? R. So now you see this log function can also be defined on R when log of something is given, right? So the domain is R. So do not go always with an assumption whenever the log of something is given. Okay, fine. The domain is, you know, that. What about the range?
1 to infinity.
1 to infinity.
1 to infinity, right? So this contradicts all that assumption, right? That log function is something, you know, whose domain is always R. No, not always R, but the domain is always when x is greater than 0. Well, this is not the case here, right?
Yes, sir. We have to just apply the definition. Argument should be greater than.
Right. So all of you clear with this now? So now shall we discuss some more questions of this type, like on more of where not nicer graphs are given, then how do we do? Okay.
Sir, your voice is so low.
Okay. Is it fine now?
Yeah, it is fine now.
Okay. So now let us deal with some questions which is not very straightforward and where it involves some more understanding of something.
Again, your voice is.
Okay. Okay, it should be fine now. Now let's do some questions which is actually difficult to really understand, and how should we actually solve and approach those kind of questions. Okay, so let's do this. Now let's take taking question number 1 here. I don't know which question number we are discussing because we discussed a lot of them. Now you have to find out what is the domain for this particular function. Okay. Now root over of, now what I'm doing, initially it was log of something, right? Now I'm mixing everything here. Okay. And we will try to understand what will be the thing. Log of 10, this is going to be x square minus 4x plus 4. Okay, so now I have to find out, okay, what is the domain for this particular thing. Okay, so what should be our approach? Fine. So we go with, again, let's go from inside to outside.
Graphical approach.
We'll do all that. Okay, so let's understand this. So now how do we do this? Now, first of all of you can start solving by yourself. We'll go from inside to outside of this bracket. Okay, so now this is log of something, and this something has to be greater than 0, right? So it has to be x square minus 4x plus 4 has to be greater than what? 0, right? So now if I have to find out, okay, which are those places which is greater than 0, okay, so I can simply write this as, if I have to factorize this and write, what do I get?
X minus 2 into x minus 2.
X minus 2 whole
minus
square.
2, x minus 2.
X minus 2 the whole square, right? Okay, so just for the graphing purpose, let me write it as x minus 2, x minus 2. And if I have to simply draw the graph, this is, okay, let me not do this that way. X minus 2 the whole square is equal, it should be greater than 0. So how will the graph look like for this?
Open parabola at 2.
So, and it would bounce
only one
from
root.
point 2.
Okay,
One
so
root,
One real root.
yeah, if this is my 2, and now we know that it's open upward, so it has to go something like this, and it has to bounce back also, right?
Yes, sir.
Right. So now over here, which are those region which it is greater than 0?
All.
No.
No,
All except 2.
From my,
X
yeah, except
belongs
2.
to R, except what?
No, when it is more than one.
2.
Except 2, sir.
Except 2, right? So now this is something I got it, right? From this part, right? So I'm done with this. Now I'm coming to this function, like this is root of something. So this, call it as 1. Now I'm going to do with the second part over here. Now I'm done with the log. Now this part, this is root over of something. Now root over thing has to be greater than or equal to 0, right? So that means log 10 x square minus 4x plus 4 has to be greater than or equals to 0. Then only this I'll get a nicer real value. Otherwise I'll get into the complex part, which is something we don't deal with, right? We have to deal with the real values, right? And domain is something defined on the real. Okay, so the question over here was find domain of f of x. This is something I forgot to write. Domain of f of x. Okay, so now we have to find out which are those region which is greater than 0. Now I know this graph I have drawn. Okay, this is how it looks like. Now all I have to do is just draw the log of this, right? Now at 2, what is happening? I have infinity, and then this is increasing and going like this. Again, if I come from this side at 2 itself, it is forming infinity, and it will go something like this. Right? So this is my graph for log of this, right? Clear? All of you clear with this?
Yes.
This is how the
Yes,
graph will
sir.
look like, right? How many asymptote it has?
1,
One.
sir.
1.
At
Right?
x equal to
Actually,
2.
2, sir.
Will the both
Actually,
curves
1 comma.
Actually, 2 asymptotes will be there.
What is that? X is
Of
equal to 2
asymptotes.
only, na?
So how
Yes,
Yes, sir. 1 asymptote
Sorry.
only.
No, but
the
when x is equal
multiplicity
to
of the root is 2, but the asymptote we are finding
asymptote is 2,
is
sir.
only
But
1,
I
right?
mean, no, that will not meet, no, sir.
Yeah, so you can say there are basically these are not unique if I have to ask you how
Uncommon.
many unique asymptote, then
So
you can
both
say
Then
that.
curves
Of course,
in
for this
the
part
right
there is one
side and
asymptote, and for the other
Yeah,
part
actually,
there is
sir.
another asymptote. You can say that, but eventually the question should be, okay,
When the
how many unique asymptotes are there, right?
Sir, at 2, will both the sides of that red color graph meet? They both
No, it
tend
doesn't
to
meet.
No,
No,
they
they
does not.
will
They does
not
not
meet.
meet. They'll not meet.
They appear like they are
Essentially,
meeting.
essentially there are two asymptotes. But if I have to ask you what is that unique, how many unique asymptotes are there? Then what is the answer? There should be one. So the question, the way we ask question will be different at that point. Okay.
Sir, it's like solution is 1, but roots are 2.
Yes.
You can say
Yes.
that way, yeah. Okay. So now tell me for which all values this is greater than 0. These are these values.
When the quadratic is more than one, sir.
right? So I just have to find out for what value this is being 0 first, right? And then I can just and after that, whichever is the greater value, it is greater, right? So I just have to find out at which value it is becoming 0, right? So I have to make sure that at which value it is becoming 0. If I have to find out, then what do I do? X square minus 4x plus 4. This is log of 10, log to the base 10. For what value it is becoming 0? This point I'm trying to find out, because after this is positive, and after this is positive, right? If I have to take it. So now which are those points? X square minus 4x plus 5. 10 to the power of 0 is 1. So it is not 4, it is 4. Okay. So now quickly tell me what is the values that we get? X square minus 4x. And if I bring it this side, so what do I get?
1 and 3. X equal to 1 and 3.
So if I bring this to this side, I get this as plus 3.
Plus 3 equal to
So when I solve this, I get x is equals to 1 and what do I get? 1 and 3, right? So this is essentially 1 and this is essentially 2, right? And I have to make sure for what all values this is greater than or equal to
1
0.
and 3.
So the next one is
3.
3.
Red 3, sir.
1 and 3.
Okay. This is something I have missed again. Okay. So this is going to be from minus infinity to 1, where 1 is included. Yes. Union. Yes.
So 3 to infinity, where 3 is included.
Max?
Union 3 to infinity. Right? Is it okay? Now this is the reason where it is being greater than 0, right?
Yes.
Right? Now what we have to do is, now we have to merge these two things. Now from here I got that this is where my x has to belong, and from this condition I got to know this is where my x has to be. Now I'll have to merge both of them. So if I do that, how do I do? I'll simply draw the line and I'll find out the intersection region for both of these. Okay. So now if I have to find out the intersection regions, let's do that. So now first of all, let me understand where my zeros, let me call this is 1, this is minus 1, this is let's say 3, and this is my real line, right? And I'm trying to find out the intersection between 1 and this 2. Okay. So how do I get this? Now this is my R. If I have to draw this green color thing, maybe I'll use a green color here. Right. So I'm just trying to draw this on number line. This is R except 2, right? So 2 is, let's say, here, right? So R except 2 means it's here, and this is what I get, right? This is how I can represent this part.
Yes.
Right? This is what I can represent it like this. All of you clear with this?
Yes, sir.
Okay.
Yes, sir.
Okay. So forget about this bending. It's like my writing mistake. Now I have to take another color and just draw this thing on the number line. This is minus infinity to 1, where 1 is included. So minus infinity is somewhere here, and this is going something like this. Okay. And this 1 is included, which I'll highlight this with a dot here. And 3 to infinity. Well, 3 is here. And 3 to infinity, something like this, right? So now what are the intersection region? Don't you see this is the intersection region till here? And this is another intersection region, right?
Same as the red one.
Yeah, let me complete this, then I'll take up things. So now what is the intersection region I get? Minus infinity to 1, where 1 is included. Union
3 to
infinity. So
But
this,
including 3.
when I take the intersection of these two things, then whatever the x value, whatever the domain value I get, this is the domain of my f of x. Okay, clear?
Yes, sir.
Okay. Yes, Mayank, tell me.
Sir, I didn't understood this. I mean, the graph between 1 to 3, is it negative? The value is negative or it's decreasing?
Between 1 to 3, yeah, it is
Yeah.
lesser than 0.
Yeah, okay. Okay.
But
By
you have to
looking
make
at
sure this is
parabola, I
greater
was
than
not
0.
able to predict that the value will be negative.
Okay. So you understood now?
Yeah, I understood.
Fine. So this part is clear. All of you can find the domain. So what we had to do here was, I'll just simply quickly tell you what is the summary. See, this is log of something, right? So then I have to make sure that this is greater than 0, right? Because my log function is defined only for the positive values of whatever this input is, right? So I have to make sure that this is greater than 0, and note this is a quadratic. So I know to draw the graph of quadratic, and it is something drawn like this. So which are those regions which is greater than 0? All these regions, right? All these regions. In fact, all these regions except 0, because at 0 it is becoming 0, which is something not allowed, which is something we cannot take, right? So x can take all the values of r except 2, right? For this particular thing. Now what I'll take over all this thing, And then since it is root of this overall thing, then I have to make sure this overall is greater than or equals to 0. Then only I'll get the real output, right? So that is what I have done. I have taken all the values of this where it is greater than 0. Now you see, we have some graphing knowledge. We can actually draw the graph for this. And when I have to take the log of this, all I have to do is just merge this, right? Right? And I have to make sure it is greater than or equal to 0, from where all it is being greater than or equal to 0. So what did I do here? I equated this with 0 just to find out what is this point and what is this point, because after this it is positive and before 1 it is positive, right? This is what we have seen, right? And likewise we have found out that, okay, when x belongs to this region, this is where this condition satisfies. Now to find out overall what is the domain for this particular function is, we have to find out the intersection region between this and this. Okay, so between this and this, now, which is this here, sorry. So what I'll do, I'll simply draw the number line, right? And I'll try to plot this, right? So x belongs to all r except 2. So which is something represented here with the blue line, I mean green line. And now if I have to plot this also, that is minus infinity to 1 and 3 to infinity, which is something I have drawn it here. Now the intersection of this thing is my domain for f of x, right? All of you clear, no? So now the intersection of this thing is that, then how do I really get this? So then I just have to find out the common points between them, and I found that this is what I get. So this is what my domain of f of x is. Clear?
Yes, sir.
So all of you clear with this? Okay. So
Yes,
now
sir.
okay. So now assuming that all of you are very smart and you can actually do basically you can actually find out do more with the graphing thing. Can you tell me what will be the graph for this particular function? Right? Interesting, right? Now we have come this far.
Decreasing now.
So just
Now-
remove the part where y is less than 0.
Exactly,
The
exactly.
red color.
Exactly. So see, now all of us are smart and we can actually draw the graph for that part as well. Now, what we have to do is, we know this. How will the graph look like for root x function? How is the graph for root x? All of you? It is defined from
Will be accepted. One will be
Decrease.
accepted, sir.
root x.
Decreasing now.
What is at 0? What is when x is 0? What do you get? 0.
0.
Yes, sir, 0.
What about -1? Can you
Minus.
take it for -1? No, you
No,
cannot
no,
take it.
no.
So what, when x is increasing, what is happening to this root x value? It is also increasing, but in a very slow pattern.
One-sided parabola.
Very slow rate.
Right?
Yeah.
Right? So over here, if I have to draw the graph of this entire thing, then I'm just dealing with this red line, right? So my 0 is okay, it is allowed for me, right? The graph for this is going to be what? This way. And for this thing, of course, negative value I cannot have, therefore I cannot deal with all these regions, right? So I can just have this and then I can draw the graph for this. So whatever you see in this black, right? This is the graph of f of x. Clear?
Yes, sir.
And what is the domain? Now match with the domain. Look at the domain. Is it matching?
Yes.
Yes, sir.
Yes, sir.
Yes, sir. It is. It is.
So is it clear now, the graph and the concepts like this? You can do questions like this now?
Sir,
Yes, sir, we
one
can.
second, sir. This side, okay. 1, it is increasing. After 1, if it comes 0 and then -1, it will stop there, sir.
Come again, sorry, I missed it.
See, for -x, it is not defined now, sir. See, after 1, it is increasing. It will not reach. After 0, it will not go, no? That line? Infinity, how it is going?
This one you're talking about, this line.
Yes, sir. Yeah.
Okay, so you just have to understand here. This is what I was trying to tell you. This is not x alone, right? This thing is not x alone. It is something, this value, right? Which is making it positive. And that is
Oh,
going
yes.
as an input for this root, right?
Okay, okay, okay.
And that is why, so that is what I'm saying. Forget about all these things. This entire thing is what? This red color thing. This red color thing is positive over here, right? So root over of some positive value is positive only, right?
Hello. Sir, you are breaking, sir.
Okay. Is it fine?
Yes, sir. Yes, sir.
Yeah. So what I meant to say is, because it's not the x alone which is determining this root function. It is this function which is determining, right?
Yeah.
So if this is positive, then this has to be some positive value only. When this is 0, then this has to be 0, right? This is what we noticed. So now, as if now all clear. See, this is so many concepts I have taught you. Like it is, first we drew the graph of log, then log of something, then log of something more. It's not a straight line, but also quadratic, but also polynomial, also like sine function, and on general log of something, right? So we drew the graph of all these things. Now we are dealing with something more. Now we did not restrict ourselves to, okay, what is the graph of log of something? We came to this also, okay, what is the log of this mod, I mean root over of something, right? And we are able to draw the graph with the same hypothesis, like not hypothesis, but the same way of thinking it, right? And you can simply draw this graph in the Desmos and you see you will get similar graph like this. Okay, so now can I understand that all of you can do the graphing parts, and given a questions like this, it is very easy to solve, no? Now with the graphing tool, all of you can solve it.
Yes, sir.
Before it was very complex. If I simply give you, okay, find the domain for this. Oh, my God, how will you apply like so many maths concepts and then, you know? So this is my approach. This is how I solve. So that is what I'm trying to share with you here. Okay. Now quickly let us see how much you know again graphings, having known that you understood something. Okay. Now let's do the graph of, let's play around with the graph. Okay. What is this graph of mod x? Okay. Now I think all of you can smartly say first I'll draw the graph of mod x, and how the graph of mod x look like?
It's the V shape, sir.
V shape, something like this, right? If
Yeah.
this is my y axis. Okay, so now all of us are very smart, and now we have to do the log of this, right? So now this is where it is becoming 0. Now I know that this is where my asymptote will be, right? And if this is increasing, so this is what it will increase. And if this is going like this, then this is what it is going to be, right?
Yes, sir.
Right? So
Yes,
this
sir.
is the graph of mod x. You can draw it. You take any mod x, you take it any tool. Okay, you will get this. Now if I have to ask you, what is a graph of this particular thing? Now if I have to tell you, okay, root over of this thing, what is the graph for this? Now can somebody tell me this?
Again, decreasing.
The
and
negative part
Negative
will
part
remove,
will be
but
omega.
Right.
increasing
Wherever this was
will
being
go
0
slowly.
and wherever this was being 0, from there it will lift and it will go in this way, right?
In a slow rate, sir.
Yes, sir.
Yeah.
Right? All
Yeah.
of us are clear?
Yes, sir.
Yes, sir.
Okay. So now we can understand that we all can do something with this, right? So graphing part is okay. Now we understood. Now let's apply some real thing here. Now I can understand that, yeah, given a question, you have one approach to solve that particular question. Okay. Now let me build it more over here. Okay. Let's go with this kind of question. So it is not always the graphing will help. There is some kind of mathematics that you have to do and some kind of analysis that you also have to do. This graphing is definitely helping you, but some kind of maths will also help you. Okay. So both has to go hand in hand. Again, graphing is a part of maths, but just to distinguish it, you know, this graphing from that, this is what I'm saying. Now, what is the domain for this? Interesting. This is something given in your activity also, I guess.
Yes, sir.
Right? Now, let's say if this is domain of f of, this is f of x, what is domain of f of x? This is my question. Now, having known whatever we have done, okay, now we shall be able to understand this. Now understand this. First of all, what is the base for this log function? I'll just draw 3 conditions from here. First of all, I have to make sure that this part is greater than 0, right?
Yeah.
That is the one thing I have to make sure. X square plus 1 and x square minus 1 has to be greater than 0. This is one thing that I have to understand from here. What is my second thing? This part.
X minus 1.
Now
should be
this
greater than
cannot be
0.
what? Now first of all,
This
it cannot be
This
one.
cannot be negative.
This cannot be 0.
sorry.
It cannot be negative
Cannot
also.
be 1 and it should be more than
One.
0.
Exactly.
Yes,
Thank
sir.
you. Thank you for pointing this. It cannot be 1, and also I have to
And
make
it
sure
should
that
be greater than 0.
It has to be
Exactly.
greater than 0.
Exactly. And now if I find the intersection of all these 3, I will get the domain of f of x, right? This is what
Yes,
I can
sir.
do more, right? Now let us understand this. Fine. X square plus 1. Is this always going to be positive? X square plus 1.
Yes, sir.
This is always true.
This is always
Yes,
going to
sir.
be positive. Now let us look at this part. X square minus 1. Okay. Now if I have to simply draw this graph and see, okay, what is happening. So x square minus 1 graph is what? This is something I can, x square minus 1 can be written as what? X minus 1 and x plus 1. This is what I can write down. X
Yes, sir.
square minus 1 can be written as this way,
Yes,
right?
sir. Yes, sir.
Now I have to simply draw the graph for this minus 1 and 1. And if I simply draw the graph for this, what do I get? Something like this,
Yes, sir.
right? So if I take the values between minus 1 and 1, this is giving me negative, right? Between minus 1 and 1, this is becoming negative. So positive by negative will make it negative,
Yes, sir.
Yes.
right?
Yes, sir.
And overall this will become lesser than 0, right? So which are those reasons what are those values where this will be greater than 0? Can you tell me? It is this region,
Minus 1 to 1.
right? So from here, Yes. So from here I can happily tell this x when it belongs to R, except what? Except what?
Minus 1 to 1.
Minus 1 to 1.
1 to 1.
Both included.
Included.
Both included.
Yes. Minus 1 to 1. If I take these values, this is where I'll get the positive value for this. And at the end I have to find out where all this was positive, right? If I take this negative value, if I take this part, minus 1 and 1 value, this was becoming negative, and overall this function was becoming negative, right? Which is something I don't have to do, right? All of you clear?
Yes, sir.
Yes,
I
sir.
have
Yes,
to
sir.
make it positive. That means this is always being positive. And if I made sure this is positive, then I will get my positive value, right? So this is the region where you get this positive value. So therefore, I have written this. So from first condition, I got one interval, right? So I got this x being this. If I have to write this in a better way, if I have to just simply write it in a number line way, so I can say that,
Infinity.
right?
Minus
Minus
infinity to
So minus
minus
infinity
one.
to minus 1 included.
close to
union,
union.
And 1 to
1
infinity,
to
1 included.
Not
Sir,
included.
we not,
Minus
we,
one is
we are
open.
not
Oh, yes,
including
yes,
minus
yes.
1
Oh,
and
sir,
1.
sir, yeah, open intervals.
Right. It has to be open interval. Why? Because the moment this becomes 1 and minus 1, this will become 0.
Yeah, so we cannot take that as well.
We
Yeah,
cannot
open
take these
interval.
values also.
Yeah, open interval.
Right? All of us clear with this?
Yes, sir.
So this thing which I was including will not be included
Sir,
here.
minus R will be included, sir.
Sorry, what?
R
Minus?
No, this is R minus, sir.
Yes, sir.
That has to be included.
Yeah, for x values, sir.
Oh, yes,
we
yes,
can
yes, yes,
include
yes.
those,
Sorry,
right?
sorry. This is included because that is something we are minusing, right? That is
Yeah.
out of thing, right? Okay. So now if I have to make sure that, yeah, for this part, it is definitely right because this is, of course, this has to be like this. Okay. Now come to this part and find out my region of x. Okay. So now for what values this will not be equal to 1? Can this ever be equal to 1?
No, sir.
Think of
It can never be
never
1.
be equal to 1?
Yeah, it can
It
never.
can never be equal to 1,
So it
right?
belongs to R.
Yes.
No. X cannot also belongs to R because I have to at least make sure that this
Yeah,
part,
I
this
mean, not
denominator
equal to
is,
minus 1.
yeah.
Yes.
So x should belongs to R, right? Excluding what? Minus 1.
Minus 1.
And if I
Minus
have to
1.
write this on the number line way, then how do I write this? Minus infinity to 1, union 1 to infinity. Right?
This
Sir,
R minus
minus
1,
one.
how it came, sir?
Minus 1.
Minus
One, it
1,
is,
sir. Minus
Because,
infinity to minus 1.
because of
Minus
if I
1.
give it minus 1, this will
Choose.
become infinity.
Oh, yeah, undefined. Okay.
Undefined.
Minus
That is
infinity
why.
to minus
Sir,
1.
minus infinity to minus 1,
infinity
sir.
to minus
Then
1,
minus
union
1 to
minus-
infinity.
Yeah.
This is minus 1 and this is minus 1.
That
I'm so
one is
sorry.
minus 1 to infinity, yeah.
Minus infinity to minus 1 and minus 1 to
1 to infinity.
yeah, that is right. Okay. So all of us are clear till now?
Sir, about the first function, x square upon x square plus 1 upon x square minus 1. Sir, are we excluding the values between minus 1 to 1, all the real values between minus 1 to 1?
Yes. So what is your question? Why are we excluding it?
Yes, sir. Why are we including, say, minus 0.75?
Minus, I didn't get minus.
Sir, the values between minus 1 to 1, all the real values in between.
Okay, let's say minus let's say 0.5. Okay.
Okay, yes, sir. Yes, sir.
Put 0.5 in this. This will become negative.
Yes, sir. It will become negative.
And this will be positive. So positive by negative is what? Overall negative.
Negative. Yes.
Is that
I
greater
understood.
than 0? Understood?
Yes, sir. Thank you.
Yeah, you're welcome. So now understand this. Over here, I think we cannot use. Okay, 1 minute. All of you understand this. First of all, over here, I know that x cannot be what? X cannot be minus 1.
Yes, sir.
Right? Now let us, here we have to do some kind of understanding. We have to make sure that for what value this is greater than 0. So for x minus 1, when this is greater than 0, right? And x plus 1 is greater than 0, then I will say this is greater than 0, right?
Yes, sir.
Or,
Sir, your mic.
okay, mic is a problem still?
Yeah. Your
Yes, sir. Voice is not
down.
down, yeah.
Okay. Is it okay now?
Still
Okay,
not
just a
up to the
minute.
mark, sir.
Not, sir.
Okay?
Yes, sir.
Yes, sir.
Okay. Okay, fine. So now when x minus 1 is greater than 0 and x plus 1 is greater than 0, then I can say that this is greater than 0, right?
Yes, sir.
Okay, so this is one condition. Another condition, when x minus 1 is lesser than 0 and x plus 1 is lesser than 0, then also I can have greater than 0 because this will be minus and this will be minus. Minus minus get
Yes, sir. Yes,
cancel
sir.
and this will be.
Yes, sir.
Yes, sir. We can say that.
Okay, so now let's understand this. For what value this will happen? X, when x is greater than 1, right? This is what I get. And from here, what do I get? X should be greater than
-1.
-1. So now if I have to merge this, what do I get?
1 to infinity.
X is greater than 1.
Should be greater than 1.
Now I'll simply
Infinity.
represent this on the number line and see this. X has to be greater than 1 and x has to be greater than -1, which implies what? This implies that x has to be greater than
1.
x has to be greater than 1, right? If I merge both of these, right? Clear with this? Are you
Yes,
Yes,
sir.
sir.
difficult?
Yes, sir. Yes, sir. No, no, no.
Right? What about others?
Yes, sir.
Yes, sir.
Okay. Now come to this part.
Sir,
Yes. Over
Sir,
here,
it-
if I take x is lesser than 1 and from here, what do I get? X is lesser than -1. If I merge this, what do I get?
X is less than
X
minus
is less than -1.
X is less than -1. Now what? Now I have to do the union for this, right?
X is
What
less
do I
than
get?
-1.
Sorry, what?
-1. Less than -1.
Less than -1, I'm sorry. Yeah. So overall, I get x has to be lesser than -1. Now, if I merge these two things, so over here I'll be doing union, right? Because this plus this, right?
Yes,
It was
sir.
or here, no? This was or.
Yes, sir.
Basically,
Yes,
the
sir.
line which I drew here, this was or condition it was telling. If this or this, then only I'll get this positive. Since this is or, then I have to do what? Plus, right? So I have to do the union. So now if I have to draw the number line from there and just simply think of it, then what are those regions which have to be, x has to be greater than 1. So which is this part, right? This is where it has to be, right? And x has to be lesser than -1. If this is -1, which is this part. So essentially, if I have to merge both of these, what do I get? X has to belongs to what? Minus infinity to
Minus infinity to
Minus
-1.
infinity to -1.
union
Union 1 to
1 to
infinity.
infinity.
1 to
Sir,
infinity.
open interval, sir.
Yes, 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 yes. 1 to infinity.
All open intervals.
Right? So now what do I get? I got 3 regions. Now this part I got, this part I got, and this part I got. Now what I have to do? I have to find the intersection between all these three. Right? This is what, no?
Yes, sir.
Yes, sir.
So many things are happening here. Right? There is high likely chances that some of you would have lost this thing. But it's okay. You can rewatch this video and this is anyways recorded. So you can see from there. Okay? So now let me just simply draw this number line and see this. Now, if I have to tell this is my real number x, where x belongs to R, now I'm just trying to find out my intersection region. Okay, so now this is all playing around with 1 and -1, and let me put it at as 0 also, so that I can just do this. Now this is 1, 0, this is 1, and this is -1. Now I'll just simply draw the number line for this first one. Okay, so now how will the graph, I mean, how will that be represented? Minus infinity to -1, so which is going to be something like this. Is -1 included?
Not included.
Not included. So let it be like this. And 1 to infinity. So 1 to infinity is from here to going like this, right? All of you clear?
Yes, sir.
Yes, sir.
Yes, sir.
Right? All of you clear with this?
Yes, sir.
Okay. So now having known these, now this is for first one. And I have to find out the intersection, right? Now I'll go with the second one, right? And I'll draw the graph for that as well. So maybe I'll just mention this is for first one. What about the second one? Minus infinity to -1 and -1 to infinity, which is something like this. So if I have to draw the, if I have to simply show it on the number line, this is what it is going to be. Where -1 is not included, so it will be something like this. And -1 to infinity is again something going like this. Correct? This is my second?
Yes, sir.
Yes, sir.
Okay. Now let me go to the third part, right? So what is this third part? I'll just draw it here and I'll find out the intersection, right? So third part is minus infinity to -1, which is not included, and 1 to infinity, which is similar to this, right? This is what it is. So 1 and 3 are same.
The intersection will be -1 to 1. It will not be there.
Correct. So if I take the intersection, this is my intersection region. And this is my intersection region. right? And in between it is not an intersection region. So overall x has to belong what? From
Minus
minus
infinity to minus
Minus
1,
Minus
union 1
infinity
to
to minus
infinity,
1, now
all
open
open brackets.
open interval,
open
yeah.
interval, and then
1 to infinity,
1 to infinity.
open interval.
so this is my domain of this particular function f of x. Clear?
Yes, sir.
Yes, sir.
Lot of things that has to be done, but of course, see, it will take time. If this kind of question is given and if you are asked to find out, okay, find out the domain for this, it takes time, right? You see, so many concepts are coming up, isn't it? So it takes time, and we understand that, yeah, even for us it will take time. For definitely 2 to 3 minutes you will have to spend for this particular question, right? So this is the way you have to solve these kind of questions. Okay, so just to quickly tell you, we did with all the graphings, right, till now. Okay, and then we talked about the domain and range and like all these kind of things, these kind of questions, like wherein you have some complex things like this, particularly this example, right? Then how did we do? There was a concept of graphings. There was also concept of obeying the function definition, right? Like whichever the function was, right? So these are certain things which you should always keep in mind whenever you are solving a domain range problem, okay? So this is one thing that I wanted to convey. Is there anything that I can think of? No, this is all fine. I think I'm done from my end, okay? If you have any questions for me, I can address that. Do you have any questions for me?
Sir, I have a last question. Can you open that log sin x graph?
Okay, just a minute. This one.
Yeah, last one.
Yeah, tell me.
So in that, the log graph will never intersect the x-axis.
It touches.
I don't know. I didn't understood that
Why?
one. Why
Okay.
it is only touching?
Okay, because what is the maximum value of sin x?
1,
Right.
and minimum is -1.
Okay, so what is log 1?
Log 1.
Log 1 is 0,
0.
Yeah, 0, 0.
right? So that is why it comes over here.
Acha, okay. Oh, okay, yeah.
Yeah,
Got
because
it.
this is where it is becoming 0. Understood?
Yeah,
Yeah.
okay. Thank you.
Welcome. So yeah, so this is all I can give it for, for this logarithmic thing. All you have to do is just do practice, okay? And you see this, I think all of you are very expert in doing the graphs and all, and see all these things does not comes like this. You will have to do some kind of practice here, okay? Even though I tell it like this, but you really have to verify this, okay? And draw the graphs as much as possible. This will help you, when you go further.
Sir,
Like
one
as
more
you,
question.
yeah.
When f of x is strictly increasing, log f of x is also strictly increasing, right?
Yes.
Same for decreasing also.
Yeah. So you keep it in mind. Log of any increasing function, let me say it like this, then this will give me increasing. Okay. Log of any decreasing function will always give me decreasing. Okay.
Okay.
Understand
Okay.
this. Okay. And one more thing, you should also know this from the linear algebra concept. When you have what do you say? Let's say if I have a function f of 1, okay, which is 1 to 1. F of 2 is also 1 to 1. Let me say f of 3 is also 1 to 1. Now if I have to take log of this will also be 1 to 1. Okay. But again, you might come up, yeah. So that is something you should.
How is it, sir?
How is it that you can appreciate better when you are coming for maths too? Okay.
Sir.
Yeah. Okay, so I think I am done from my end. If you have
Sir,
any
only for
questions,
1 to 1 or on to also there is something like this?
on to you cannot say. It is just for 1 to 1.
Okay.
Sir, if in exam, in multiple choice question, and they say that which log graph are matching with each other, and in option they have given the equation. So, is there any fast way to solve and get the answer?
Basically a graph is given, and then how do you actually find out the equation, right? Okay, so Okay, so
They just gave you the equation and you have to draw the graph.
they just gave me the equation for that particular thing, and then I have to draw the graph for that.
Option A, one equation, option B, another equation, option 3, some other
You
equation.
have to simply draw the graph. Don't look at the option. Simply draw the graph and match your graph with the option. That's it. Right?
Okay.
What will be the graph for this, all of you? No, I mean, not the graph for this, because I think you guys are smart to tell this. I don't think so. Like, I can give any question wherein you cannot answer now. Yeah, because I believe like.
So one just question before we move out
That's
of
a laugh.
context. You just said log of f1 plus f2 plus f3 is 1, 1 if all the three functions are 1, 1. Does it work both ways? Like this is 1, 1 means they are also, and if they are 1, 1 then
you
they
can
will
say
also.
this. You can say this.
Okay, double
Yeah?
both ways it will work.
Right, right, right. But again, respect the domain at each interval. Okay?
Yes, yes.
Yeah. All right. So this is all from my end. And if you think, then we can end our session here.
Sir, I have a question, sir.
Yeah.
What if I don't know if it's true or not. I just want to ask you this, if it's true or not. So if a function is strictly increasing, can we say that the function is 1 to 1?
Yeah, you can say that.
Okay, sir. And another thing, sir, if any log function, let's say any odd degree, like we know any odd degree polynomial could be 1 to 1, or it's like not always, but they're like mostly 1 to 1. For let's say x cube, it's a 1 to 1.
Yeah.
So what if we take the log of x cube? So we are getting like let's take the natural logarithm like ln. So it like by like not by the graphing thing, we can also say that log of x cube is a 1, 1 function, right?
Yeah, you can say that. But again, your log function will be defined from where?
0 to infinity.
Yeah, so it's going to be something like this.
Like this, yeah. Okay.
Right?
Yeah.
So it will be log of this, and now you notice this log of this is again 1 to 1. So the claim was, if this is 1 to 1 function, and if I take log of this, then it is going to be 1 to 1 function, right?
All right, got it. Thank you.
ln natural logarithm also follows all these
Yeah,
same
all
properties.
that greater than 1, all that greater than 1 will work. E is some 2.7 something, right? All that will work.
And what for is less than 1, all this graphing?
What if I give you log of pi x minus 1, right? Do not get scared now, right?
Yeah,
all you have to know is pi is nothing but some values, 3 point, something.
Yes. Now I'm asking, how do we approach it in between 0 and 1, the base, the graphing?
Okay, so you can just think of now. You can see, I gave you one concept that's you can consider as a homework, and you can start thinking of it, right?
Okay.
Yeah,
Okay.
do that part, because if I'll tell everything, then what will you do? See, because I'm out of question, what should I give you now? Because if I give you anything, you'll be able to answer it. Okay, so one thing that you should keep it in your mind.
Your voice is weak.
Okay, one thing that you should keep it in your mind whenever you're solving these kind of graphing questions, I mean this logarithmic function, is be thorough with your properties of logarithm. Okay, so there are only 2-3 kind of questions that we can ask you, right? One is like, we might give you an expression and then we expect you, okay, fine, what is the final value that you get, right? What is the x value or whatsoever, right? So that is something out of properties you get it. There is no graphing and all will work. It's a pure maths, right? So that is one thing. When you're dealing with something like finding domain range, graph will help you for sure, no matter what. And there are directly one questions on graph, that is something we can put to you, right? Like, okay, this is the thing. Okay. So essentially why I give emphasis to this aspect is because you see, this thing you will not learn elsewhere. This thing you will not learn as you go in maths 2 component or as you go higher degree courses, right? It's just that I'm pretty sure if you're knowing this now, as you go, let's say for maths 2 component where you have fully mathematics, then you shall be in condition to say, okay, this is what the function is, right? This is how the graph look like, right? And then understanding that particular concept becomes very easier for you. even when you go to your machine learning algorithm, when you're learning these kind of various algorithms, this will definitely help you at that point of time. Okay, so this will definitely help you in terms of visualizing something. Okay, so if you are to ask me in terms of whatever you have done till now, is which all graphs are really important, right? Straight line, quadratic, exponential, right? Then logarithmic, and then there are certain other graphs like 1 by x. What is a graph for this, right? You should know these graphs.
Yo, chat.
Right?
So I really want to know your honest opinions on the fact that Bernard wants the group to be multilingual in the sense that it allows the fact that other languages can also be spoken.
Sorry, what? Hello? Hello, am I audible?
Yes, sir. Yes, sir.
Yes, sir, you are.
I didn't get his question. I'm sorry. Can you repeat again?
I don't think he was talking to us.
He was telling some Bernard and regional language, something like that.
But I think it was unrelated to the class.
Okay, fine. All right. All right, then. I think we can end our session here, and we
Sir,
can.
sorry to remind you that I'm still stuck in that question itself.
Which question?
That x minus 1, x minus 2, x minus 3, x minus 4.
X minus 2, x minus the log of that polynomial.
Yes.
Why you have stuck there?
No, sir. I mean
Tell
the
me.
2 to 3 thing.
2 to 3 thing. Yeah, tell me.
Yeah,
Okay,
if
fine.
I take 2.5.
Okay, first understand this. Tell me, what do you get? What is log 10?
1.
1.
No,
Okay.
sir, I'm
What is?
asking about
I'll come
this
to that. I'll
specific
come to that
question.
part. What is log 9?
Less than 1.
What
number.
value?
I might not know the exact value, but
Okay. What is log 1 basically? Come to this now. What is log 1?
0.
Okay. And before this, whatever I take between 0 to 1, what value I'll get? Lesser than 0?
Yes.
Lesser than 0?
Yes.
So if this value, this peak value, if it is lesser than 1, then will this ever cross log of that lesser than 1 value?
No.
It will not, right? So if this peak value is, if it is lesser than 1, then definitely this will never cross this x-axis. Now you're able to understand this?
Yeah, I'm saying that only. Yeah, it will never cross. That only I'm saying.
Yeah. So what is the confusion? Okay, you just wanted to clarify this?
Yeah.
Okay.
But it will never cross. Yeah.
Yes.
In this specific question.
Yes. So this is all, and then you can actually practice more questions. If you have any doubt, tomorrow also we have one more session. It's like solve with TA. So TAs are basically that will be first session of you with the TAs. So these TAs are basically students like you, okay, who have entered higher degree courses. Like some of them are doing diploma courses, or some of them are doing, some higher degree, like they have entered in a degree program and all this. So based on their score, we took them interview and everything, and they are the most capable guys. They have scored 10 CGPA, I mean 10 GPA in this particular thing, and they are really smart in terms of this particular thing is concerned, maths one. So if you have any doubt, you can ask them there too. Okay, they'll help you out. So this is all for today's session. Have a I hope good night to all of you.
Thank you so very much.
Thank you, sir. Good night, sir.
Night.
Thank you so much.
Thank you from Naren.
Thank you.
Yeah, thank you.
Thank you, sir. Thank you so much.
Thank you, sir. Good night.